Okay, this is our last slide, right? Where I want you again to try to glue everything together, put everything that we've seen so far, and try to make sense of it, right? From the state machines, the graph theory, and what OSPF does with all this, right? So basically, we're gonna see here, and we're gonna see this in more detail in the capture. So don't worry too much if this is maybe not that clear. But basically, we have here the state machine, right? The state machine, how it goes, and what the different messages the neighbors exchange, right? So first, they exchange the hello packets, right? So they become neighbors. Once they are neighbors, they start sharing the database descriptors, as we saw earlier. And if you see here, we have the initialize, the more, and the master bit set. That means that when this is happening, right, they are basically defining who's going to be the master, who's going to be the slave. After they define that, they start actually exchanging database information, right? At this point, they're just negotiating who's going to be the master, who's going to be the slave. And from exchange down to loading, they're going to be exchanging actually database information. And once they've done that, they're going to say, okay, if I'm seeing from the other descriptor that I don't have some, or I'm missing some of the LSAs, I'm going to start sending requests and looking for updates, right, to make sure that my database is up to date. Okay. We're going to see this again in the next part with the capture. That may be more graphical. Finally, once we have our database filled up, right, that means we can start running our dear Dijkstra or SPF algorithm, right? So basically, primarily in the case of a single area with the link state advertisements type A and type 2, what I basically have is a view of the network as a graph, right? Because if in this case, if I'm router 1, once I have all the LSAs from my neighbors, I will be able to build it in my database. I will be able to calculate the graph with the network topology that is in my area. And once I have that, because I have the cost, I have the other nodes, and so basically I have my nodes and I have the edges and I have the cost to reach each of the nodes, I can run my SPF calculation. So at the end of the day, that's what OSPF does, right? It creates a graph with information on its database, and it starts calculating the cost to reach each of the neighbors. And basically, with the rest of the LSAs, with the rest of the information on the LSAs, I will know on each node what networks are attached, right, to each of my neighbors or to each of the other nodes on the graph. So as I already know from R1 what's my best cost from R1 to R2, or from R1 to R4, or from R1 to R3. In this case, this is very simple, but let's suppose I have a more complex network. Doesn't matter. R1 has the network topology built, and it will know the best path to reach each of the nodes. And because of the LSAs, it will know the networks attached to each of the nodes. So basically, I know the cost to reach my node. I will know the cost to reach each of the networks attached to each of the nodes. So that's basically it, guys. I create my graph. I calculate the cost to each of the nodes. Then I just know what networks are attached to those nodes. I know the cost to reach all those networks.